Hi, third period. This is Mrs. Lasner. I wanted to finish off the examples in your note outline through a video so that you had something that you could look back on if you got stuck on the homework. So just as a quick recap, these examples are taking advantage of these three properties: the product property, the quotient property, and the power property. And these properties of logs are completely related to the properties for exponents. So remember that logarithms are simply exponents. They follow the same rules that exponents follow, which is why if you have a product of things inside of your log, you will be adding the individual logs. If you have a quotient, meaning division of things inside of your log, you will be subtracting the logs, because subtraction of exponents is how we divide these results. Similarly, addition of exponents is how we multiply these results. And then if you have a power of a result, so this m was the result of raising b to some power, and then that result is being raised to a second power, that power gets multiplied to your log, since the log is the original exponent, the exponent that resulted in m. So these properties can work both ways. That's what this vice versa part means. I can either take one log and split it into two through addition, subtraction, or I could take a power inside of a log and bring it out in front using the power property. But I could also go backwards. So if I was adding two logs, I could put them back together again into one log using a product inside the log. If I was subtracting two logs, I could put them back in the log using division in the log. And then if I had a coefficient of something outside of the log, that can become the exponent of the thing inside the log. So I can use these properties in either order. So in the first example, we were using the properties to condense. That's when you want to take multiple log expressions. Here I have three of them, and I want to somehow end up with one single log, and then all of that stuff is inside of it based on how it would work with the properties. So I think the first thing I'll start with is the power property. That is the property that says if you have a coefficient being multiplied in front of the log, that number can be moved inside the log and become an exponent of the thing inside the log. So this expression can be written as, so I haven't done anything with log 5 yet, but the 3 log of x could become the log of x to the third power based on the power property. And the 0.5 times the log of y could become the log of y to the power of 0.5, or 1/2. So that first property I used was the power property. Then the second thing I notice is that I am subtracting these two different logs of 5 and x cubed. So those can be put back together into one log using the quotient property. And that property says that if you're subtracting two logs, that means you're subtracting two exponents. The only time we subtract exponents is if we're dividing the results of those exponents. So the log of 5 minus the log of x cubed is equivalent to the log of that quotient, 5 over x cubed. Meanwhile, I'm still adding the log of, and I'm going to rewrite y to the 1/2 as the square root of y. So that's just a little side note. I'm going to put a little side note here that y to the power of 1/2 means the same thing as the square root of y. And oftentimes when we're working with these log problems, we will rewrite a 1/2 power as a square root. Okay, but then the very last thing I'm going to address is this addition sign. And to combine those logs together, I'm going to use the product property of logs. And the product property says if you're adding two logs, those logs again are representing the individual exponents of these results. So if I was adding those exponents, that must have meant that these results were multiplying together. So this log can be put together through multiplication. So 5 over x cubed times the square root of y. And then when you're multiplying a fraction to like a whole number, in this case it was the square root of y, I can think of that as being over 1, and then I can just multiply straight across. So for my final answer, which I'll write up here, I would have 5 times the square root of y in the numerator divided by x cubed times 1, which is just x cubed. So this is the condensed version of this expression. This expression is equal to the log of 5 times the square root of y divided by x cubed. So that's how the properties work to condense. Now in example 2, we're going to look at how we can expand a single log using those same properties. So for this one, I'm going to start with the product property because I notice I have a product of 4 with x and x with y cubed. I have 2 separate products. So I can think of this one log. This is a log base 2 of this entire product. That log is the exponent of whatever this product is. But the way I find the exponent of a product is by adding together each of the individual exponents, aka each of the individual logs. So I'm adding the log base 2 of 4 to the log base 2 of x, and then adding that to the log base 2 of y cubed. Okay, then just based on what a log means, I know that the log base 2 of 4 is 2. And that is because 2 would have to be squared in order to result in 4. And the log is the power. So the log base 2 of 4 is 2. So I will kind of think about my expression in that way. So I have 2 plus the log base 2 of x plus the log base 2 of y cubed. And then the only other thing I can do to fully expand this is to use that power property again. And that is because I noticed my y here was being cubed. So that is the same thing as multiplying this log by 3. So my fully expanded answer would be 2 plus the log base 2 of x, and then plus 3 of the log base 2 of y. And that is as far as this can go because there's no other quotients, powers, or products. Then in example 3, our goal is to evaluate. That means I want to get an answer that's a number. So I'm trying to figure out like what power would I have to raise 6 to get 4? Or what power would I have to raise 6 to get 9? And I'm coming up short because 6 to the first power is 6 and 6 to the second power is 36. And already raising 6 to the second power gives me something bigger than 4 and 9. So this will be one of those scenarios where maybe I can combine these 2 logs into one log. I notice the logs are adding, so I'm going to combine them using the product property. According to that property, the addition of logs means that we were multiplying the result. So this power of 6 was getting multiplied to that power of 6. 4 times 9. And then that results in 36. And I can easily evaluate that log because right here, 6 squared is 36. The log is the power. So this sum of logs must equal 2. And it was much easier to evaluate by using this product property than trying to find each of these logs separately and adding them. Then the last one on this outline is probably what I would consider the trickiest because you have to really understand what you're being given. So I want to point out it's the log of A that equals 1.5 and the log of B that equals 3.2. A does not equal 1.5 and B does not equal 3.2. So we have to wrap our head around that and understand that these are the exponents. 1.5 is the exponent. So I could say that 2 to the power of 1.5, that equals A. That's true. And I could say that 2 to the power of 3.2 is equal to B. That I can say. But I can't, and I don't want to plug in 1.5 for A or 3.2 for B. Instead, what I will do is I will use the properties to expand this log to be able to get expressions that just have the log of A and the log of B. I'll start in this one with the quotient property. And I'm going to write the log base 2 of a squared b over 16 as a quotient. The log of the numerator minus the log of the denominator. And then I'm going to notice that I can evaluate the log base 2 of 16. That would just be 4, since 2 to the power of 4 is 16. This log would be 4. So then I get log base 2 of a squared times b minus 4. So I have part of my answer has been evaluated. I just need to figure out this part. And so then I'll move on to the product property, because I am multiplying here. So that would turn into addition of the individual logs. So I get log base 2 of a squared plus the log base 2 of b. So whatever those things are, I'm going to subtract 4. And I know that the log base 2 of b is 3.2, so I could swap this out for the value of 3.2. Okay, I'm also noticing that I can use the power property here to make that a coefficient of the log of a. So now I have the log base 2, now I have 2 times the log base 2 of a plus the log base 2 of b, which is equal to 3.2, and then minus 4. So I've evaluated these parts. I also know that my log base 2 of a is 1.7 or 1.5. It says it right here. So now I have values for everything. I just need to put it all together. I have 2 times the value of 1.5 plus 3.2 minus 4. So 2 times 1.5, that's 3. 3 plus 3.2 would be 6.2. And then 6.2 minus 4 would be 2.2. So my final answer for that last example would be 2.2. So that finishes up our 6.4 lesson, and I hope that this helps you with your homework and also in prepping for your quiz coming up on Monday. See you then. Bye.